Hi there everybody, today we're going to look at lines of best fit. You will have come across these probably in lessons in science and in various different aspects. It's normally we get a bunch of data which is plotted and in relation to looking at that we're trying to find is there a pattern developing in between them. Alright, so essentially in the correct terminology, a line of best fit is drawn to show the relationship between two different variables. Okay, so it might be a variety of different things in trying to kind of see if there's a pattern between two things taking place. So I suppose a good example would be is the sale of ice cream when the weather is hot. Okay, so you tend to see a pattern developing there is the increase in weather, the more ice creams that tend to be sold. You'll see that one no doubt in books and assessments and all those kind of different things, but of course it could be anything. So the line follows the same direction as the points. And when drawing a line of best fit, you should try and draw it so that there are about the same number of points on either side. Okay, please make sure that you understand that just because there are points, that there is not necessarily a relationship there, but obviously you're trying to see if there is one, essentially. All right. So if I look at this particular example, hopefully you can see that there seems to be a tendency for this graph to kind of slightly go upwards as we progress to the right hand side. So if I was going to do a line of best fit, I'm going to try and draw a line that roughly fits in between those, or maybe I've got 4 on one side and 4 on the other side, or something looking like that. And of course it is a bit of an estimate, it is a bit of a guide, but if you're asked to draw a line of best fit, then you're looking to try and go through that. Please note that it doesn't have to go through 0, 0, it doesn't have to go through this point in the corner. I think some people think it must, but no, not necessarily. We're just looking to see the trend. And then I put a line which best fits it. All right, so don't expect it necessarily to go through the 0. And of course, you've got one like this one, which is going down. All right, so this one be at what we call positive correlation. It goes up, and there is another lesson on correlation, but this is going upwards, and this is going down. So it's got a negative correlation. So you'll have a line of best fit looking something like that. And then, of course, if you've got something which is a little bit more all over the place, so we're still looking for something similar, and hopefully you can still see the sense to be still a slight trend for it to kind of go up. So you'd expect it to, again, to be somewhere in the middle. All right, but I'll stress it again, doesn't have to go through 0. Don't expect it to necessarily go through 0, and there is no exact perfect answer. It's about trying to get it near enough and using that line normally. Okay, right, so here you go. So I mentioned there, line does not have to go through 0. Okay, so predicting values. All right, so basically you're going to have something similar to what you just had, like a scatter graph, and then you're going to use your line of best fit to predict an outcome. All right, so here we go is a graph of weight and height of 10 dogs. Obviously, so the bigger the dog, the heavier it gets. Common sense, really. So at the minute you've just got a bunch of results. So for example, they've obviously taken a dog, measured its height, measured its weight, and plotted it, and they've done that 10 times. And they've got a graph looking like this. All right, so first things first, we need to have a line of best fit in order to answer the question, which asks us to estimate a 16 kilogram dog. So 16 kilogram here, it is basically where would it fit in here. All right, so we draw the line of best fit, trying to get it down the middle. Again, remembering that it doesn't necessarily have to go through 0. All right, so it doesn't have to. Question is does it need to go to here? So anything that's got no weight is a very, very, very small dog indeed. It doesn't exist. All right, so I guess it would have no height. So probably it should go through 0 in this case. Anyway, right, so in terms of estimated, so we're looking at 16 kilograms, and then we're going to go up to this point, and then we're going to measure across. All right, so we expect it to be around about 25 centimeters. All right, so like I said, no one is expecting you to have this absolutely perfect. What we are saying to is once you've drawn the line of best fit and it tends to be roughly in the correct place, then using your line of best fit is what they're looking for. All right, so they would expect you to draw a line up, draw a line across, and then highlight what this number is, and then explain that you would expect the dog to be around about 25 centimeters tall, which is what's come from here. All right, so from 16 up you go, and then across and measure the height, and then using the line of best fit, we're estimating it's 25 centimeters tall. Okay, so estimating the weight of a dog which is 55 centimeters tall. So we're going to find 55 on here. Going to move across to around about here, and you can see from our line of graph it just goes past 40, so maybe about 41, 42, or something like that. Let's have a look. So 41 they've gone for. All right, so as long as you're drawing the lines across and the lines down, then you'll be all right. Okay, let's have a look at another one. So which prediction is most reliable? All right, so what do you think, which prediction is most reliable of the two? And any reason why? The first prediction is more reliable because the estimate lies within the data points. All right, so when we're talking about, so I'll go back a little bit so you can explain. When I was looking at this one over here, this one goes outside of our data. All right, it's outside our data. Our data is kind of, it goes up to around about 36 kilograms and about 55, about 53 tall. All right, and down here, it goes down to around about 6 and around about 12. All right, so in terms of our estimate, one of our estimates was right in the middle here, so 16, wasn't it, in the middle of our data, and then the other one was outside our data. All right, so based on our data alone, this is why we think that that one is more realistic. So the relationship could change outside these values. All right, so while we've got line of best fit that fits this bit, would that continue all the way? All right, and I guess it probably wouldn't, because you wouldn't have a dog that would just get bigger and bigger and bigger. It would get to a point where it's not going to get any bigger. All right, so if you think about a 60 centimetre dog, it's about half a metre tall. Well, how tall will a dog get? All right, so he's only going to go to certain criteria, but then in terms of the weight, then I guess that would probably flatten off as well. All right, so try and think about that really, really carefully. All right, so that's what that's talking about. So the one that's most reliable is the one that fits within our current set of data. All right, and that's roughly about it, other than one last little bit, something called an outlier. So something that might skew your results. All right, so if you're going to look at averages or doing something like that, sometimes an outlier has a massive impact, and it's normally an anomaly, something that doesn't quite fit in the normal criteria. Okay, so it doesn't follow the same pattern as everything else. So outliers can occur in human error. So maybe you're looking at data specifically and making an error in judgment. It might be you're writing dumb numbers down, and you might write an extra zero in error, making it 10 times bigger. Alternatively, you plotted them wrong. All right, it's easily done when you're trying to plot the numbers. And then in some cases, it's just extreme values. All right, so when we're talking about basically maybe temperatures or something like that, or rainfall, it might be that one particular case, something happened on one particular day that's really kind of skewed it, and it's kind of a freak occurrence. All right, so something like that, something has a big impact on what we would say is typically a normal average kind of scenario. Or of course, false information. Maybe someone's lying. Someone said to you, maybe you're doing a data on number of siblings, and you ask the question to everybody, and everyone's saying 1, 2, 3 number of siblings, and someone says, "Oh, I've got 48." Well, clearly that's not right. But ultimately it's the data, and of course you're misinformed. All right. So look at this set of data, like we had last time. You can hopefully see pretty obviously there's one number that kind of is completely wrong there, and you can see it's right up the top here, right at the top. There it is, kind of standing out a mile. So what we're saying is a dog which is 55 centimeters, half a meter tall, is only around about 2 kilograms. So that's not going to happen, is it? It's not going to happen. So it might be a case of when we're talking about kilograms, someone might have thought, oh, it's stones instead, so different units maybe, or I don't know, or maybe it was not 2, maybe it was 20, so it should have been over here somewhere. All right, and that's more likely to be the case, isn't it? I don't know. So height of something 50, 20 kilograms, maybe over there. Maybe not. I don't know. But it's still clearly not quite right. All right, so we can kind of ignore it. All right. So, but again, the reason I mention it and the reason we're talking about it is because you could well be asking the question, how that might impact your data and what difference that would make to your line of best fit. Well, it doesn't fit, doesn't it, at all? So I can't really consider it, so kind of ignore it. So there you go. So that outlier is most likely to be due to an error. It's unlikely that 2 kilogram dog is 55 centimeters high. Okay. All right, so that is, in essence, a line of best fit. All right, so just to kind of clarify, it's a line that goes through the majority of points where it tends to take a pattern. You're trying to get half on one side, half on the other side, and then just to kind of reiterate, it doesn't have to go through 0, and be wary of numbers which are outside what we see as our pattern outliers, so to speak. All right, so please go to maths-school.co.uk, so maths-school.co.uk, have a look at some questions to practice on, but of course, please feel free to visit the video at any time. Thanks for listening.